Patterson. Today, I'm going to show you how to do a Bradford assay. Bradford assay has many different applications, but today we will be using it to determine the concentration of a protein that we extracted in the lab from E. coli. For this experiment, we're going to need two different micropipettes, a P20 and a P200. We're also going to need P20 to 200 tips. We're going to use a 96 well plate. We also will use Bradford reagent, some diluent, and we have our protein that we extracted in the lab, and we also have commercial version of this protein, which is alkaline phosphatase. Now, our 96 well plates look exactly like this, right? There are 96 different wells, each one holding up to 300 microliters of solution. There is a notch at the top where you typically start, that's A1. So it goes 1 to 12 horizontally and A to H vertically. Before I start with a 96 well plate, I always like to label the top with the wells that correspond to the wells that I will be using. In this case, I'll be using 12 wells. So I'm going to label 1 to 12. This is important because you may be working on a well and you forget or you get distracted. You can always come back and cover it and figure out where your well is. All of our 10 wells will receive 200 microliters of Bradford reagent. So I'm actually going to pipette that first. I will reuse the tip for these wells simply because this is a clean, unused plate. So I know nothing else has been here that will contaminate the solution that I'm about to use. If this is a plate that's already had chemicals in it or has chemicals in it, you need to switch the tip out after every well. All right, so here's my Bradford reagent that I diluted earlier. I'm going to pick up my P200 micropipette, set it to 200. Okay, I confirm that I am at 200. Put the cover to the side. All right, and again, I am going to reuse the tip because this is a unused plate. Right, so I make sure that the tip is firmly on there. So to pipette, I'm going to press the plunger down, go into the solution, slowly release. I'm also going to look at the outside of the tip to make sure there's no liquid left on it. This assay is very sensitive, and 1 drop of liquid can actually change the concentration of what you have in the wells. So it might be good also to sort of wipe the tip on the side of the tube before you dispense the liquid. So I'm going to go right down inside the plate, release. All my wells now have 200 microliters of Bradford reagent. I do have a container for my tip waste, so I'm going to put it to the side. Now, I'm going to add different volumes of diluent to each well, as specified here on my protocol. So this is the diluent. So our first 2 wells will get 50 microliters. I will be changing the tip after each one as I'm going into the Bradford reagent. If I don't change the tip, once I come back in the solution, I will contaminate it with the Bradford reagent. So it's important at this point, since there's already stuff in the wells, to change the tip. So 50 microliters go in the first 2 wells. Now it's important when you're using these small volumes to mix your solutions together. So to mix, I'm going to go into the well. I'm going to release down to the first stop, and I'm going to pipette up and down 10 times to ensure that my solutions are fully mixed. So again, I'm in well number 2. Up and down 10 times to mix. We're not going to the second stop because that will create bubbles, and this is a very sensitive assay. All right, my next 2 wells will get 45 microliters. Now, something that I noticed here as I'm picking up, you guys may not be able to see it, but there is a small amount of solution on the side of this tip. So I'm putting 45 microliters into well number 4. If this solution gets in there, then I may be introducing something like 47 microliters, which will change the concentration. So again, make sure that your tip is free of any liquids on the outside before you pipette. Now our next 2, 5 and 6, will get 40 microliters. Seven and 8, we'll get 35. And 9 and 10, we'll get 30. So we've just added our diluent, right? Now we are adding our BSA in wells 1 to 10. So wells 1 and 2 will actually get no BSA. That will be our control well. Wells 3 and 4 will get 5 microliters of BSA each. So I'm going to use my P20, set it to 5. Again, we'll need to change the tip out. Again, it's imperative that you don't introduce more than that 5 microliters into the well. So make sure that there are no droplets on the outside of your tip. So wells 3 and 4 will get 5 microliters. So I'm going to go into well 3 and I'm going to mix. Once the protein, the BSA, comes in contact with the dye, it will change from reddish brown to blue. And we can see that happening right there. Wells 5 and 6 will get 10 microliters each. This one's a little easier to keep track of what well you've had solution in because they're changing colors. Well, 7 and 8 will get 15 microliters each. And wells 9 and 10, 20 microliters each. Oops. Now I'm going to stop here really quickly, and I want to show you the difference between mix-in and non-mix-in. Wells 9 and 10 have the same solution in both, same volumes of everything. You can see that there's a difference in the blue hue between 9 and 10, whereas 9 is pure blue, 10 you can see a little bit of red-brown, and that's because you didn't mix the dye and the protein properly. And as a result, if we run this on the spectrophotometer, you'll see that there's a difference in the absorbance value. So I'm going to go ahead and mix right now. Well 11 will get our enzyme that we extracted from our protein. We're actually going to add 50 microliters of that, so I need a P20. Set it to 50. Okay, so I'm going to add 50 microliters of our enzyme that we extracted from E. coli, 50 microliters into well 11. It's turning blue immediately, so we know definitely we have protein present. That's always a good sign. And well 12, I'm going to add 50 microliters of commercially available protein. In this case, it's alkaline phosphatase. That is what we isolated, and we bought some commercial one so that we can compare the values to the one that we isolated. Very blue. Now we're going to cover this and incubate for 10 minutes. So to read our 96 well plate, we're going to use this program, Gen 5, which is a microplate reader program. We already have protocols set up to read Bradford assays, but you can set any protocol up you want at any wavelength you would like to measure your solutions. So while we wait, I'm going to remove the cover from the plate, and I'm going to put it here on the plate reader with the A1 corner in the upper left-hand side. Okay, let's make sure that this is set for 595 nanometers. It is. All right, so it says place the plate on the carrier, which we did. Make sure it's a 96 well plate and press OK when ready. So we're going to hit OK. The microplate reader does not know which wells you have solutions in, so it will read every single well, all 96 of them. And so we know that we have solutions in wells 1 to 12. Any other wells, the other 96, will give you values, but they should be less than 0.05, so they're negligible. The plate reader has now finished, and we can look at this data and do a qualitative analysis right now. And so we can see that our first two wells, the absorbance value is low, 0.3, and we expect that because we didn't put any protein in these two wells. However, we have increase in protein concentration from wells 3 to 10, and this is reflected by the absorbance values as well as the shades of blue. As you can see, it gets bluer the more concentrated your solution is. Let's take a look at wells 9 and 10. 10 was the one that was not mixed properly, if you remember, and so the value is a little lower than well 9, even though they have the same solutions in them. Well 11 is our protein that was extracted in the lab from E. coli. It's a pretty high number, 1.2. It's higher than the baseline, so we know that we have quite a bit of protein there. That's great. And well 12 is our commercial alkaline phosphatase. Once you're finished, remove the plates. You can take a record. You can take a picture of this image, and then also you can save it to Excel by pressing this button here, and it will have all of your data here for you.